Okay, so I did the math prior to this video because it's kind of dark and I wanted to be able to get close enough to where you could see it. So we have a proton moving in a circular orbit with, so we have a proton and it's moving in a circular orbit with a radius of 150 millimeters. And it says that the magnetic field is uniform, perpendicular to the circular orbit, which that's nice. That's a 90-degree angle. So if we had to calculate anything with in relation to the magnetic field, we would be in luck. But in this scenario, it is asking for the angular frequency. Hopefully, okay. It is asking for the angular frequency, the period of motion, and the speed and the kinetic energy. And so first, we're going to find the angular frequency. And we do that by taking the charge times the magnetic field divided by the mass. And so I Googled what the mass of a proton was because it wasn't given in this problem. But Google did tell me that the mass was 1.67 times 10 to the negative 27 kilograms. And then we know that the charge of one proton is 1.6 times 10 to the negative 19 coulombs. And then in this problem, it gives us the magnetic field being 0.25. And so we can plug that into our angular frequency equation and get 2.4 times 10 to the 7th inverse seconds as our angular frequency. And so then it asks for the period of motion. And so this is a time period, T. T is time period. We used it in lab, and it is equal to 2 pi, as we're going a full circle, which is 2 pi, times mass divided by charge and magnetic field. And so we take 2 pi of the mass, and then we divide it by the charge, 1.6 times 10 to the negative 19, times our magnetic field. And we get that it takes the proton, it takes it 2.6 times 10 to the negative 7 seconds to travel the circular path. So it takes it this amount of seconds, and that's a very small amount of time. So the proton is moving through the circular path in a very short period of time. And then the reason that we did period of motion first is because we're going to need it to find the speed of the proton. And so the speed of the proton is 2 pi, once again, a circular path, 2 pi times the radius divided by this time period. And that's going to help us find meters per second. And so we take 2 pi times 0.15 meters. The reason we take 150 times 10 to the negative 3 is just easily wrote as 0.15. And then we divide that by 2.6 times 10 to the negative 7 seconds, which we just figured out above. And we're going to get that the speed of the proton is 3.6 times 10 to the 6 meters per second. So kind of like I was talking about up here, how it travels in a short distance. We're also seeing that the speed is very quickly, um, which goes a lot. These kind of confirm each other in their relationship. So we can figure that we're doing the math right. And then our kinetic energy, so the kinetic energy of this proton is half times mass times the velocity squared. And velocity we just found up here, meters per second. So we're going to do, so then we can plug this one into that. It's really nice that we can, that we did it in the right order to where we're figuring out things as we go along that we need for the next equation. So I took half of 1.67 times 10 to the negative 27 kilograms, which is one proton, and then times that by 3.6 times 10 to the 6 meters per second squared. Very important that you square it. Don't forget. And then what I got was 1.1 times 10 to the negative 14 joules. So that is this proton's potential kinetic energy that it can reach. And so we have successfully solved all parts of the question.